Alright, welcome back. I was playing around for today, had a bit of time, so I decided to, record. And I managed to get the shotgun working, and I managed to get the camera view thingy working. So, without further ado, we got our little guy, or we got our main character here. He has a function or a script property that's called physics controller. We're gonna go in there first, and we're gonna add a function called auto rotate. So we added that in our header right here, auto rotate, and what it's gonna do is it's gonna check the angle between where we're looking at and where the camera's looking at, and it's gonna rotate the guy to stare at it. So to do that, we're gonna go into Unigine, math, and we're going to use the vector 3. We're going to have camera view, and we're going to have player view. So those are the two that we're going to use. The camera view is going to be the Unigine game get player, and then we're going to get the world direction. Now we just need the direction that it's looking at, and since it's default at looking at like this, is default looking forward when we say NZ, we're just going to leave it like that. And then for the other one, player view, we're going to take the node, because it's already on the main node, world direction, and we're going to specify Unigine, and we're going to specify the math and the axis y. So that's our forward vector. Now what we're going to do is we're going to store this on a float, and we're going to call it angle, and we're going to use a function inside math. As always, math has everything, get angle. So and we're going to use this overload. What it does is it takes the two vectors and then it compares it to its up, so it deletes that, and then it's just looking at the, in our case, up is z, so we're going to look at the x and y, and then it's going to look at the difference between the two vectors, and then it's going to give us the angle between them. So we're going to choose our camera view, our player view, and the up we're going to choose is node get world direction, and we're going to specify the direction as up, axis z. Now that is going to get our guy to auto rotate. Now we're also going to have to change these angular impulses to linear impulses, so when we move up, down, left, right, it's going to move like a checkerboard. And then over here, that's going to be an x, and this is going to be an nx. So x is right, and x is left, which is our a. So if we were to test it, it's going to work, but we don't have that long of a time. Let's go here, and I'm going to go into our shooter CPP animation, which has our main function, which it shouldn't, but for now it does. I added one thing, which is a Unigine vector node pointer, and not a regular standard vector, but a Unigine vector. I don't know the difference, but it worked with that. So, and then we're going to have the shoot shotgun in our case. So if I were to go in here, then we're going to have our little thing. So how we're going to do the shotgun is actually going to be the lazy version. We're going to have something called a frustum, or a frustum, or however you say it. A frustum, or a frustum, is basically the viewing of a camera. But what we're going to do is we're going to make this side our shotgun muzzle, and that the spread of the shotgun. So it saves us a little bit of time from coding everything. So how we're going to do this is actually we're going to use something called materials and quaternions, or 4x4 matrices and quaternions. So we're going to go into Unigine, math, and mat4, so matrix 4, and we're going to call this one the frustum, because this is going to have the frustum. And then we're also going to have one that's called the view. Now frustum is going to be the size of this cutout pyramid, and what it's going to be is we're going to use, again, Unigine math, and we're going to use perspective. Perspective gives us that camera perspective that we're looking at. So we're going to choose some commas here so we can see it. So first is FOV, field of view. I'm just going to choose 40. The aspect ratio, so if you're someone who knows all this mathematical complexity, go ahead. I'm just going to choose the ones I chose. And then N and F are basically near and far, how close it is to the position and how far it is. So we're just going to choose 0.05 and 4, so it's about 3.95 meters long or something. All right, the next thing we're going to do is we're going to do a mat 4. So a unit mat 4 view. So this is called the viewing of a frustum. Now we made the size, but we didn't show how we want it to look or where we're looking at. The viewing matrix is what we're looking at, so we need to make it so that it's looking straight. So how we're going to do that is we're going to go into the here, and it says it needs a quaternion and a vector. So the view and the position. So what we're going to do is we're just going to take a line up, math, and we're going to do a quaternion. And we're going to call this quaternion the rotation. And we're just going to do it over here. And over here, the rotation requires either an axis angle, and there's a few of them. What we're going to do is actually we're going to take the rotation of our object that we're looking at. So get world rotation, okay, and then we're going to times it by 90 degrees. Now the reason why we're timesing it by 90 degrees is because on default all frustums face downwards, so we're going to have to times it. So we're going to do Unigine math quaternion, and then we're going to give it 2 commas, the one that asks for angles. So we're just going to rotate it on the X by 90 degrees. So if you had a line that just cuts through it, rotated by 90 degrees, it's going to be facing forward like this one. Okay, so that's going to be facing like forward, and this is going to make sure that it's looking exactly what we're looking at. So now the view rotation, we give it the quaternion, and then we give it the angle, or where it's supposed to be sitting on. So we're going to do the gun get child 0, so that's the trigger point, and then we're gonna do get world position. Okay, so now it's sitting at the world position, and it's both looking from where we're looking at, it's looking from where we're looking at, and it's facing what we're facing at. So that connects all that. And to make sure that we're right, we get a visualizer, and we do a render frustum. It's going to ask for the projection, which is going to be our frustum. The size, the projection is what it's looking at, which is the view, and then a color, which is basically Unigine math vector 4 underscore black. Okay, and just to make sure it works. So now we can see that, oops, looks like it's not rotating. Probably didn't write it down. Okay, so now we have it, and it's doing it correctly. Now the reason why it's not rotating is because we didn't tell it to rotate. So we go back into our physics controller right here. Because we got the angle, we didn't actually use it. We're gonna do the object body rigid, which is our main character. And then we're gonna do add angular impulse. We're gonna use the node get world direction, and then times it by angle. Alright, so now it's rotating correctly. We take this, and now it's rotating exactly where we want it to rotate. It's doing a little jiggle because the equations, or the angle that it's rotating by, is a little bit slower. but that's okay. So now it's rotating correctly, the rendering's just taking a few frames less, and now we have that little area that's the shotgun. So if we go in here, and now if we were to write, if we click the left button, then we wouldn't shoot, but we're gonna do something else. So first, let's capture it in a visualizer. We'll do green, just so you can see it, okay? And then we're gonna choose 2 as in 2 seconds, the duration of how long we want it. So that's that. But how do we actually capture it in an intersection? So remember how we had our node pointers? We're gonna capture it in the object captured. So first things first, we're gonna do objects captured dot clear. So there should be no objects that have been captured before, or if they were, they're gone. And now the next thing we're gonna do is we're gonna do something called world bound frustum. So before we even do that, we're gonna write it in a very simple Unigine math world bound frustum. Too bad I can't find it. And we're just gonna name it BF and give it a bracket. So now when we do a thing over here, it has a few functions. This is the one that it's gonna take all the time. So first, it's gonna take the bound frustum, and it's gonna take the inverse transformation, or it's gonna take the projection and the model view. So for us, what we're gonna do is we're gonna take the projection, which is going to be our frustum, and then it's going to take the model view. Now the model view is going to be actually the opposite of, or the inverse of, the rotation view. And I have no idea why it does this, but I was stuck over here for a while, but I figured it out. So we go into Unigine math inverse, and then we inverse the view. So now we have this as our world intersection. This is our world intersection, okay? Now what we do is, now we go into Unigine world get intersection. We have two types. We have visible and intersection. Visible requires you to put a camera and how far you're facing. We're not going to do that right now. We just want to capture everything inside this little box. So we're just going to put some commas, and it's going to tell us what we need. We need, there's quite a few of them, but the one we're going to use is going to be this one. So it's going to be the bound frustum. The type, so Unigine node, and then we're going to choose the node type object mesh static, and then it's going to ask for the node pointer, which is basically objects captured. Alright, so that's going to do that. Now the object mesh static, you can choose any type, but it's going to pick up everything. And since the sun is infinite, it's also going to pick up the sun. But because we only have these three objects, which are object mesh static, we just want to pick them right now. So then we're going to do a for loop, because it already caught them all. We're going to do a for loop. We're gonna loop through the objects captured.size. Okay, and then we're just gonna do a simple log message. We're gonna do a simple percentage s, and then a /n, or \n actually, and we're gonna give it the objects captured I, and then the arrow get name, just to see if it actually captures it. So we're here. Let's get this guy. Okay, let's do this. So when we click, we didn't capture anybody, and you can see the little green didn't capture. Now we have this guy. So if we click, we can see on the top left corner, we captured medium boy, and if we click these, we captured both the big boy and the boy. medium boy, big boy, and the boy. Alright, so it did get captured, and that's about it from me. I will try to do something else later on, but for now, that's it for how we get the shotgun. We also have one more equation over here that I don't use because I need to use it only on half of the guy. So this function is basically when we're aiming, the guy would move, but he would also be tilting. I want him to only do it when he's like, you know, only like his spine moves, not the whole body. Because this gives us also the problem where if we're looking too far up, right, he is going to be tilted. Now, we don't want that. We're gonna have to fix that later on, but for now, I'm just gonna mute that. And yeah, that's about it. I will see you guys later, probably AI or enemies or something else. Or we can do something completely different. Anyways, I'll figure it out. Alright, that's enough talking for me. I'll see you guys later. Goodbye.